Switching to an open-source operating system like Linux or macOS usually comes with a persistent friction. The moment you migrate to a new, incompatible system, you discover that specific productivity software and video games simply stop working, as they require the specific background services only found in Windows. For decades, the standard workaround for this problem has been emulation, or running a complete virtual machine. This diagram illustrates the performance cost of that approach. An emulator forces your computer to dedicate heavy processing power to simulating dozens of complex layers of an entirely different physical computer, all just to power one single application at the top. It forces a choice between two compromises. Users must either suffer through a sluggish software experience or abandon the operating system they prefer just to access their essential files. In June of 1993, a group of developers discussing Linux on Usenet began questioning that model. They asked why they needed to simulate an entire physical computer system just to open a desktop application. Their solution was to bypass hardware simulation. Instead of building a fake machine inside their computers, they would intercept the software's instructions and translate them into a language the host system already understood. They named the project Wine. It is a recursive acronym standing for Wine is not an emulator. By removing the need to simulate a secondary operating system, the computer can process the program at native-level speeds without the traditional overhead. To understand how this translation works, you have to look at the Windows Application Programming Interface, or API. This is the language a program uses to ask the operating system to perform basic tasks, like opening a file or drawing a button. A Windows program sends an instruction block labeled User32 toward the operating system. Normally, an incompatible OS ignores this request. But Wine intercepts the command instantly, converting it into a POSIX call the host understands, allowing the instruction to slide through to the hardware. Because it functions as a real-time interpreter rather than a full system simulation, Wine removes the memory and CPU penalties that typically limit virtual machines. Building this translator was difficult because the Windows API was proprietary and heavily undocumented. Many programs relied on obscure, unlisted software behaviors that Wine had to replicate perfectly. Project leader Bob Amstad and developer Eric Youngdale spearheaded the task of writing an alternative translation dictionary completely from scratch. In 1994, leadership passed to Alexandra Juilliard, who has managed the project's coordination for the 3 decades since. Volunteers relied on black box testing, feeding inputs into Windows programs and observing the outputs, to map out the software logic without seeing the original source code. Over a 15-year beta period, developers adapted the software for 32-bit architecture, eventually contributing to a codebase of over 1.4 million lines of C code. What began as a niche experiment grew into a massive reverse engineering effort, mapping the internal logic of the world's most dominant operating system. After 15 years of continuous development, Wine reached version 1.0 in 2008, establishing its first stable release for general use. This milestone brought formal corporate support. Companies like CodeWeavers began employing developers to work on the core project, ensuring the translation layer kept pace with new versions of Windows. As software moved toward hardware-accelerated graphics, Wine evolved to translate complex DirectX 3D instructions into native Linux and Mac graphics languages. This progress led to Valve's Proton, a specialized version of Wine that allows resource-heavy Windows games to run on handheld Linux hardware like the Steam Deck. A project that started in 1993 with 16-bit desktop apps now provides the infrastructure for high-end PC gaming on entirely different operating systems. Looking at the 3-decade history of the project, the cumulative work of these volunteers has changed the relationship between software and the operating system. Wine creates a path through the technical barriers that traditionally restricted software to a single vendor's platform. For millions of users, this provides the ability to switch hardware or choose an open-source OS without losing access to the software they have purchased or developed over years. By treating the operating system as a language to be translated rather than a boundary, this community has turned interoperability into a standard feature of the modern desktop.